First you will see. So let us do that thing. So it is gone, right? It's gone.
Yeah.
Suppose it is improved. It is getting improved up to a certain level. It will improve. Again, you go to the same direction. Forget about it. Again, it will be. It is going down only, not going. It's not going to be better.
I got it.
Yeah. Then again, see now what I am doing. I am getting it rectified, but I don't know up to which point I have to go. So I'll keep on doing this, and I will see the change where it is better up to certain point it will be better. After that is going bad only.
सर यहाँ तो आपको पता था कि हमने अभी वाई का चेंज किया है, पर एक्स का कब करेंगे और वाई का?
आप कुछ भी कर दीजिए, अभी आप कुछ भी कीजिए, मैं देखूंगा नहीं. आप किसी भी डायरेक्शन पे मूव कर दीजिए.
तो और बेटर हो गया सर.
मैं बोल रहा हूँ आप खराब कर दीजिए किसी भी डायरेक्शन पे मूव करके, मैं देखूंगा नहीं. क्या आइडिया ये है आप किसी भी डायरेक्शन पे रोटेट कीजिए. पहले सिर्फ एक को पकड़िए, एक डायरेक्शन पे रोटेट कीजिए. सपोज आपने रोटेट करना चालू किया क्लॉकवाइज चालू करने के बाद सिर्फ आपको इमेज नहीं देखना है, इमेज बेहतर हो रहा है या नहीं हो रहा है, वो तो देखना ही है. देखना ही है. उसका स्टिग्मेटिज्म का रिजल्ट क्या होता है? समथिंग व्हिच इज सर्कुलर इज गेटिंग इलॉन्गेटेड. आपको इलॉन्गेटेड फीचर नजर आएंगे. तो आप जब उसको करेक्ट करने की स्टार्ट किया आपने, तो आपने क्लॉकवाइज स्टार्ट किया, तो you can understand that your elliptical thing is getting into circular one and it is getting rectified. तो आप सोचेंगे कि मैं सही डायरेक्शन पे जा रहा हूँ. अगर उल्टा हुआ तो रॉन्ग डायरेक्शन पे जा रहा हूँ. तो सपोज आपने सही डायरेक्शन जाना स्टार्ट किया, एक पॉइंट जाने के बाद आपको उसके बाद आपको लगेगा कि नहीं ये खराब हो रहा है, तो द मोमेंट यू स्टॉप देन यू गो फॉर द स्टिग्मेटर एक्स, दूसरा वाला सिमिलर वे. दोनों एडजस्ट हो गए, उसके बाद फिर से आपको फोकस करना. दिस इज द वे.
Sir, what about the wobble sir was telling?
Yeah.
सर व्हाट आर वी एक्चुअली चेंज बाय द ब्राइटनेस बटन? तो
वो थोड़ा सा वो इमेजेस जैसे कई बार थोड़ा डार्क में कोई
उसके अंदर क्या हो रहा है? ब्राइटनेस पे वाले बटन से हमने कुछ किया, तो अंदर क्या हो रहा है उसके इलेक्ट्रॉन बीम के साथ? क्या
there is an amplification factor actually. वेक्टर तो वो आपको एक एम्पलीफाई करके सिग्नल दे रहा है.
ओह ओके, दैट्स अ सॉफ्टवेयर थिंग.
Yeah, I mean brightness contrast because the number of electrons that is signal yield, जो सिग्नल जा रहा है वो तो आपको चेंज नहीं है, वो तो केवी से या प्रोब करंट से चेंज होगा.
ओके ऑलराइट.
और मे बी डब्ल्यूडी अगर चेंज करेंगे तो सिग्नल यील्ड पे इफेक्ट आएगा, बट एक्चुअली इट इज द सिग्नल यील्ड इज एक्चुअली सेम बेसिकली. यू अंडरस्टैंड?
यस सर.
एक्चुअली पिछले बैच को दिखा, ओवल एकदम परफेक्ट था. ठीक है,
ओके.
पिछले बैच तब दिखा है, तो ओवल को हम लोगों ने जानबूझ के गड़बड़ किया. हाँ सॉरी, जल्द गया मतलब
सैंपल बर्न.
No. Sample has not been burned. Okay, you are getting some black image, black spot.
Yes.
This black spot is not because of the sample burn. No, because there are some gaps here, or there may be difference in the plane of the surface.
Okay.
Actually, basically that may be the reason, because you remember the shadowing effect. So basically, if there is in plane, then from the other part of the surface the signal will not go to the AC
Okay,
detector.
okay.
So you will get some black spot. That may be the reason that here actually. So if your oval is perfect, so how will you do that? Okay, I am going to say again for the. So here we have a button, oval. We go here, we click here, and here we could not see
Oval.
anything. Then we to understand what is there, we increase the scan speed. Okay, we can go to 3
Okay.
and now you see one particle over here, right?
Yes.
You can see the particle over here. So the particle, it is actually getting focused and defocused. If it is on the same point,
Okay.
then
It will get
you will
focused.
understand, you'll understand that your beam is absolutely perpendicular. It has no bending and all those things. If it
Okay.
is not on a single point, it is focusing and defocusing on some other points. It's focusing in some point and again it is defocused, it is moves away. Then you will understand that your oval, you need some corrections in oval. But remember one thing, that you do oval correction only when go to very high magnification.
Okay.
If you are taking 2000, 5000, 10,000, 20,000, even 50,000, not very much required. Go to 1 lakh, then
Okay.
go for a oval correction. Otherwise, oval correction not that very much
Required.
required. Okay.
Okay.
Maybe you can try. I am not saying you don't
For
try.
learning purpose, we can try.
Try, but
Okay.
it's not really required at the lower magnification.
Got it, sir.
Yeah. So now here actually just to make you understood, I am actually reducing this particular amplitude. We can increase the amplitude and can see that there are some changes. In you see it is actually moving. It's actually moving. So we need to control it actually by using this aperture Y. I am actually destroying it actually. The oval.
Okay. Totally destroyed.
Totally destroyed. You will not see anything actually. You cannot see. So the same way, the same thing, that
Okay.
you go to a particular direction and you'll understand the effect of that particular your action
Yeah.
onto the image, and you do accordingly. If it is improving, you go on and stop at a place where you think the improvement is absolute best, and otherwise you go to the other direction. This is the idea.
We have to do it very patiently.
Yeah. So when you are doing the very magnification, then only
Okay.
you do this kind of thing. Otherwise, it is not getting improved actually. Anyway, I'll do the needful. Anyway, these are the things. There are few things which you can use here. These are the few marker that you can understand your particle size and all those things. What is the difference? So there are few markers are available over here. You got my point? Shall I?
From where we are
This
you
one,
are
this one.
guessing.
These are the few markers or measurement
Okay,
you
okay.
can do. Okay. You sorry.
Okay.
A particle size measurements, or if you have any flex kind of a structure in your structure, you can understand what is the length.
Okay.
If you want to write anything, you can use these things. So anyway, there could be plenty of things, but these are the few critical things that you can see. You can also see that what is the effect of
Yes.
this changing of
Energy.
the accelerating voltage. Yeah. So basically, what I think, remember, Ron has shown one image where if you reduce the accelerating voltage, your surface property, the surface image is actually getting improved. Why? Because the more accelerating voltage you apply, the signals you are coming not from the surface but from the beneath the surface.
Okay.
But there are lots of noise
Defects.
signal mixing actually from the surface, also the beneath the surface, and you'll get noise, and your surface
Overlapping.
the image of the surface getting blurred.
Okay.
So here you need to optimize which accelerating voltage you need to use and what exactly you need. Okay. Suppose for EDS your accelerating voltage should be more or your probe current should be more. But for the imaging, maybe you keep the accelerating voltage at nominal level to understand the surface property, because this is the surface imaging tool only. So these are the few basic things. Now we can go for the hands-on actually. Ron, are you there?
No.
Yeah. Anything to add? I mean, I try to cover
The basic operation is there. I heard you give a different explanation on photos and stuff.
yeah,
Hands on.
hands-on.
Yeah.
So
Anybody want to try?
you want to? I mean, how we will go to? You are the one who will be operating first, or they are the one? You.
I think we're waiting
If
for
you
the-
guys are there,
What we can do is this image, we disturb something, we disturb the focus, we disturb something, ask them to fix.
Okay. How many of the 20? You are 20 days?
18.
How much? 18. And they are?
They are also 18.
Total
Total of 36.
20.